Welcome back. If you are a CTF player, you already know that the CTF is over. However, we are going to reveal the answers and the podium right after this talk. So I want to welcome on stage Mikko again, who was bored over 2 years and thought, well, why not to search for vulnerabilities on his MacBook? So Mikko, the stage is yours.
Thank you, BB. Hello, everyone. It's great to be on the stage, a second round. Yesterday I was talking more about the escaping from the isolated networks and environments, but today I'm going to talk more about some of my hobby projects which are related to the vulnerability research, what I've been basically doing during the last 10 years while working in the cybersecurity, mostly as a hobby. So, my name is Mikko Kenttälä. I'm founder and CEO of SensorFu. I'm also a happy hacker, so I've been doing plenty of hacking as a hobby, as a side, and at the same time, I've been doing it also as a profession. So I have a fairly long background of doing technical security audits also, so many of the skills and the lessons learned comes actually from that era, so I use the similar kind of approach most of the time when I'm doing some of the hobby hackings. I'm part of the many other associations also, so but that's about that. So let's dive in about some of the vulnerabilities what I found from the macOS. Previously, and today, I'm not going to talk about this specific vulnerability too much, but I managed to find out a zero-click vulnerability from the macOS mail, and with that, the attacker was able to get access to the victims' all the mails in a way that if attacker just sent an email including a couple of zip files after the victim received the email. After that, all the future emails were basically forwarded also to the attacker. So pretty severe issue. And since I have a good amount of time today, I quickly show you a bit of the details how it went. You can find out the full blog post about it from the internet anyway, but in a nutshell, the thing what happened with that vulnerability was the fact that the attacker is able to craft an email which included 2 different zip files, and when the email was sent to the victim, when the victim received the email, that email will be checked and the email client will find out that there's a zip files inside of it and automatically start to uncompress those and extract those for later use. And because there was a specific header called xmac auto archive 1, which basically means that the mail client knows that the sender has actually drag and drop some folder to the mail client, which will be automatically compressed. And when the receiver gets the email, it will be also automatically extract. So it's smooth ride for the user of the macOS mail. However, since there was an issue related that how the system or the macOS mail handled the temp files, when the first zip was actually extracted, it included symlink, which were basically pointing to the configuration folder, and when the second zip is extracted, that data will actually go to that via that symlink to the configuration folder, and that way the customers or the victims configuration related to the email was changed, and after that all the emails were also forwarded to the victim. That's it in a nutshell. So logic bug over there, and I'm really into different kind of logic bugs, so you're not going to see some buffer overflow exploitation with my presentation, but these are more like exploiting some of the functionalities which might be, or the logic issues in some of the softwares in macOS. But at the beginning, I will show you a video which demonstrates the things what I'm going to walk you through today. So in this video, you immediately see the proof of concept, but we will dive into all the details during this presentation. So this is the same video what I sent to the Apple and as a demonstration. So I will just quickly show that this is the Pixel-specific version. I saw that the system integrity protection is enabled, which is one of the security mechanisms. I show that there's a secret desktop file on the desktop, which should not be normally available, even if you are using your own terminal and you try to check that what's on the desktop. You are not allowed to do that. You need to give a specific permission for it. So now victim is triggered or tricked to go to the specific URL, which basically prompts that you want to download the file. And this is the one click which is needed to exploit this whole chain of different security measures. So now the user downloaded a file from the web server, and the next time when the user is opening terminal, you can see that your machine is owned. And now we are taking the sum over of the TCC, which is one of the security mechanisms. And now we have access to the desktop also, and the attacker have had a way to run the code on the system. So I will walk through that what happened actually over there under the hood. But before that, I want to provide you and highlight how I normally approach this kind of systems. So I normally find some vulnerabilities which are rather simple techniques or fundamentals. And obviously I have the experience, 10 years experience from the technical security audit, so that is helping that I've been spending quite a lot of time of doing something similar before. But I just used common tools to actually do the tracing and the reverse engineering. But the first thing for me always is that learn as much as possible. So I typically check some documentation, but I specifically do reverse engineering. So I try to point and click all kind of things and see what kind of functionalities there are. And every time when I see some interesting functionalities which seems to have surprisingly, which might provide avenues to get to some hidden functionality or surprising powers to actually access to some other files in the file system or something like that, I get interested about those. But the goal is to know exactly how the system and the software what you are researching is actually working. And I use tools, rather simple tools, like I use tracing. So I run dtrace, for example, in macOS, and to trace all the syscalls, so I can see that what the software is actually doing, what kind of files and system calls the software is doing. I use the TCP dump to actually dump the network data, and so on. So really good analyzing tools for binaries. I use strings normally, just to get the hunch that what's actually going on. And then the goal is to find the anomaly. So when I poke around, I play around with the software, whatever I am looking, I try to cause some error in the system or the process. Since I know that how the system or the software should normally work, at least I have an assumption that how it should go, I try to poke around. If I have an input where I can put some data, I try to put something which may cause an error or cause something else to happen. And if I can find something like that, that is the place where what I try to exploit later on. So maybe whenever you find some interesting error, it might be also a new avenue and a potential place where you can do the exploitation, because it might mean that you are ended up being in from the logical point of view, you are in the situation which is maybe not considered by the maker of the software. So there's an error, so maybe there's some room for you to actually cause some more troubles and maybe use that as part of the attack. Okay, But there's in macOS, there's quite many security mechanisms which are trying to stop you of doing all kind of hacking. So to achieve code execution with one click, we need to evade actually multiple different security measures which are in place in macOS. So even though you are able to exploit the initial vulnerability, you need to evade gatekeeper if you want to get own code running on the system. And the gatekeeper, I will explain soon that what that actually means. Then if you want to get access to some data in the system, you need to evade the TCC, which was the piece of security measure which actually tries to block your access to the sensitive data or sensitive files in the system. So when you saw the video, I was running the terminal, I wasn't able to access the files on the desktop. The TCC is the control mechanism which is actually blocking that. And if you want to get rid of the TCC, you need to actually evade the zip protection, because zip protection, which is in the kernel of the Mac OS, is protecting the most valuable parts of the operating system. So it's in kernel level, and you cannot, it is trying to block that you cannot manipulate, for example, the TCC database and so on. And I will soon describe these different security mechanisms a little bit better. So for the ones who have been using the Mac OS, you have most likely seen the gatekeeper. Every time when you try to download some software or application from the internet, it is typically blocked by the gatekeeper, which is giving you good information that, oh, this is downloaded from some place. Are you really sure that you really want to run it, and so on. And it is blocking that by default. So this need to be approved by manually via a graphical user interface, typically. Only exception is that if you download and install these applications from the Apple's store, then you don't need to go through this path. But because you can still, which is a good thing, run applications which are downloaded from the internet, this is part of the process how you get the system running. So this is a gatekeeper. Then there's the TCC, which stands for Transparency, Consent, and Control. This actually is a rather cool feature. I personally like this a lot, that there's this kind of configuration available. So you can actually configure based on the application that which of the application can access your camera, which of the applications can access to your files, which of the applications can access to your sensitive data in other places. So you can quite nicely control with that. So every time if some of the software, like a Spotify, want to access to download folder, you need to give the consent for the application to actually do it. So this is rather good thing. So by default, there's only the application's own sandbox is writable for the application. So this consent need to be given specifically. Then the SIP, the system integrity protection. It is protecting the most valuable things on the Mac OS. You saw the example, and I actually explained this already. But this is a kernel feature which is protecting the specific files and the configurations in the Mac OS system. And even if you are root, you are not allowed to change some of the files which are protected by the SIP. If you want to debug something or access actually those files as a user, you can do it in a way that you put your system on the recovery mode and disable the system integrity protection from there, and then put it back to normally, and then SIP is not protecting those files. This is handy also for the security researchers to actually test and find out new things. So that's a good thing also that it is available and it is possible to disable it. The good thing is also that you cannot do it from the normal operation when your OS is booted normally. Okay, but let's dive in to the actual vulnerability chain. The name of the game is that the alias file to rule them all. This is how we can get code execution with one click and with the in the way that it will compromise also user sensitive data. By the way, these words are used specifically because this is also how Apple describes that what are important for them. So they are worried about the 0-click and 1-click vulnerabilities. So how much the user have to have the interaction if there's vulnerabilities. So if you're exploiting those, how much the user need to have a how much the user need to do to get that exploit running. And if you are exploiting the system, can you access the sensitive data, which is described as the personal files, calendar, email, photos, so on. So this is also important for them especially and for the users. But phase one, you saw the video. The first step over there was the 1-click. So user accepts the file to download. And that file was actually a zip file, which is downloaded. And after that, macOS is infected. And what happens under the hood is that the zip files in macOS are considered as safe files. And for that reason, when you are downloading zip files with Safari, those will be automatically extracted. And typically this is not maybe a big issue, but obviously I started to think about this as an attack vector because there's some things which are happening automatically, immediately when you receive some file to your system. The file includes, the zip file actually includes an application. In macOS, applications are basically certain folder or the directory which includes different files in a certain manner. So it's described quite well that how it actually works. But this case, it includes application and the actual binary, or at least which is normally binary. In this case, it is alias file. And this is because the alias file is in macOS is not like similar as in symlink is in the Unix systems or so on. macOS alias file is actually rather old technology. It's originally built into the System 7 31 years ago, but it is still up there and functioning in macOS. And it's quite good that it is over there, but also in this vulnerability chain, that was also the entry point. And that is because with the macOS alias files, it can also point to the external resources. So not only to some file in your own system or maybe in the disk image or something like that, but it can also point out to the external Samba server or FTP server or so on. So in this case, I made an alias file which is actually pointing to the Samba server. So then after the file is downloaded and the zip file is extracted, there will be the application folder. And macOS, as in many other operating systems too, have an automated index system, which will check out certain details and files if those are arrived to the file systems. So every time when you have a new file in your system, some of the services will get the notification that, okay, there's a new file, and there may be automation to check out that more details or metadata related to that file or so on. This applies also for the application. So when the file is written to or extracted from the zip file to the file system, the process called LSD, which is Launch Service Daemon, which is running on the background, will automatically go and check out all the files or some of the important files related to that application, including the main binary. And when, in this case, since the main binary, instead of it having, it's not the binary, it's an alias file, the LSD process will automatically resolve that alias, and it will follow the link and try to check the file from there. And because it's pointing to the external Samba server, it will automatically also mount the external Samba server in this case. But so what? Now attacker can trigger Samba mount, but what you can do with that? But obviously at this phase I got some kind of hunch that this is definitely going to some place, so I just need to figure out that how to actually leverage this to get more access on the system. So Samba mount obviously may include some malware or something like that, but typically you still need to have the interaction with the user to get that running, and I would like to avoid that. And even if you have something over there, the gatekeeper will be blocking running the code, which is in the external resource. So that was not something what I wanted yet. But so when the mount will happen, it normally in macOS, all the disk images and network shares will be mounted under the /volumes. And normally, the last part of the path of the URL is used for the naming of the folder under the /volumes. But because I'm the attacker and I'm in this case able to control the fully the URL, I was thinking of that maybe I can do some trickery to actually make the file mount or the network share to mount to a completely different path, and maybe I can find out the code execution via that way. So I tried the most common things like try to mount the network share to ... and so on, but none of these tricks actually worked well, unfortunately. So I was banging my head to the wall and trying to figure out what to do next. But at some point, I found out anomaly. I found out an anomaly which was related to the common trickery used with the characters, and that character was null. So if I used the null character at the end of the URL, which is the pointing to the Samba mount, for some reason the naming failed in a way that instead of the last part of the URL, the naming went in a way that the fully qualified domain name was used for the folder naming in a way. So I was able to cause the system to fall back to some plan B related to the creating the folders under the /volumes. But I started to think about that maybe I can use that. And I configured the wildcard domain name for the testing. So I was thinking of that maybe, even though with the I tested the parsers in a way that can I do ... trickery for the naming, and those didn't seem to work. I was thinking of that maybe if I use the fully qualified domain name, it might actually work, and maybe there's a different parsers which will go through the actual file or the actual URL. And this was the solution. This might be a bit hard to read, but I will walk you through. So first, we break the naming, and that's at the null at the end of the URL. Then we use the leverage that, because this null will cause it to fall back to the plan B to use the fully qualified domain name for the naming. So we start to use the wildcard domain name. We leverage that and do some encoding to make it actually work in a way that this represents the ... /private /temp/test. And for some reason, maybe it was related to the domain name queries, and I need to have the valid domain names. I needed to use the double encoding over here. So you can see at the first characters over there, I have a %25, which is basically %. So I needed to use the double encoding to get this working. But then I have the rest of the fully qualified domain name, which won't be handy without the null character over there. So what this means that I terminate the string with yet another null, and that way the rest of the domain name is not actually used for the naming. And now I have a mount point, and I can control it. I can point the mount point to any part of the file system. But there was some limitations. The folder or the directory cannot exist in the system already, so it needed to be a new directory, but otherwise it was working. So now I had the chance to actually cause a mount, Samba mount to arbitrary path in the system. But I still don't have the code execution, so how the heck I'm going to do that? So this shouldn't be, typically this part shouldn't be that hard. So if you are able to mount or put your own files to almost any point in the file system, you should be able to find out the way to get the code execution also. So typically you want to find out that if there's an software plugins what you can use, or maybe some configuration to use to that when the system is operational normally, those will be loaded every now and then, and maybe your code will end up being used also. But there was a couple of speed bumps. The gatekeeper once again was blocking the binaries which are not already allowed to be running. There was a sandboxing, and surprisingly hard part of this exploitation was the finding out the mount point directory which is new in the operating system. So this is like a silly speed bump. However, this was one of the most difficult one to actually find out. So the gatekeeper is blocking the binaries to running. So I was testing a bit about the one option to get some plugins running from the plugin directories of different applications. In theory, it should have worked, but there was a gatekeeper blocking those every now and then, so it wasn't helping. So, but I found a solution at the end of the day. It was to use, I found out that, that there's a specific folder which is not in place, which is used by JetSH, which is the default shell in macOS. So that was the most straightforward way to provide the POC to this exploit chain. So I mounted the network share to that folder or directory, and every time when the terminal is launched, it will be automatically initialized and all the code over there will be run. So it was, after all, rather common way to get the code execution in that sense. It just happened to be surprisingly hard in this scenario. And the gatekeeper is not blocking this because the application is totally legit, which is the terminal. So when the terminal is running, there's obviously nothing fishy with that. And when the shell is running inside of the box, that's also totally legit, but it will load a configuration which will actually include my shell script, including all the parts what I'm going to cover next. So, how to get the access to personal files? So we already covered that there's a TCC in place, which is preventing the softwares to actually access to some of the personal data in macOS. So just a reminder that it looks like this. This might be, if you're using macOS, it looks like this. Every time when you get the pop-up, it's related to the TCC. And what this means in practice, that the TCC, under the hood, there's a specific file or the database in the user's home directory, which is the TCC database. You cannot access it even if you, when you have user permissions to actually, from the traditional Unix point of view, you should have access to that file. In reality, you don't have access because the SIP is preventing you to access it, except with the way that there's a graphical user interface which needs to be used by user. You can manipulate that database with that. So there's a specific permissions for that application to actually edit the database. But if you're trying to do it from the terminal, you should not be able to do it. or from the any other application. So since I wanted to have access to all the personal files, I wanted to try to get rid of this functionality. And the zip is protecting that, so I need to find out the way to actually how I circumvent the zip protections related to the TCC database. What happens under the hood is that the TCC database is automatically read on every boot by the process called tccd. And the tccd process is owned by the user. So this was immediately something what I was starting to thinking of, that, okay, I'm already in with that user permissions from the traditional Unix permission point of view. So maybe there's some leverage that what I can play around or arrange the typical ways to fool the environment or fool this kind of situation is that you actually change the environment in a way that, since you as a user have a permission to kill that process and so on, you may cause some surprising situation for the process where it's loading the data actually from someplace else. So whenever the tccd process is starting, it will automatically load the TCC database in the background, and I needed to find out the trick to fool the tccd. And this will do the trick. So, and I have to be honest with this was a lucky shot. This was, I think, the first or second thing what I tried, and it worked. And what happens over there is that I kill the process. I immediately after that mount new directory, which is on the protected path. So instead of the original file, which is protected by the SIP, is still there. The file handle is over there and so on. But since I mount a new directory or new image which is mounted to that directory, whenever the TCC process is starting again, it will just go to that path and load the new database from there. And since I've done the mounting over there, it will actually load my TCC database. And obviously, in my TCC database, it's really liberal in the sense that the terminal is capable of doing all kind of things, what are over there. So, and the cool thing about this is that the zip is working as expected. So zip is still protecting the original file. However, it's like under the hood, and if you try to access the path, you are actually in different place in file system. So success. Now attacker can have access with one click, or attacker can cause a arbitrary network mount and get the code execution done via that way. And that way we have also access all the user's secretive data. And after all, this was a bumpy road, so there was plenty of speed bumps. It was nice ride, and in reality, I went through now this chain as a logical order, but in reality, I solved these puzzles here and there. So it wasn't in the same logical order. So I didn't start immediately from some place and went it step by step. Every now and then, since there was issues, I needed to go back and check some other things just to get my head resetted at some point. But what happens over here, just to recap it, the initial access is achieved with the fooling the user to download zip file. That zip file will be downloaded and extracted automatically by the Safari. LSD, which is the background process for the indexing, will automatically index it. And since one of the files is actually alias file, LSD will resolve that alias, which is actually pointing to the external Samba mount. And with that URL trickery, fooling out the mount path to completely different path what it should be. The next phase will start the code execution and privilege escalation whenever the user launches the terminal, which can be considered as a normal usage of the machine. It's not the best demonstration, but since this is not the vulnerability part, that how I get the code execution in that sense, that there's nothing to fix from Apple related to that. This will do for this demonstration. The malicious configuration will be loaded when the terminal is launching, and that way I can get my scripts running on the system, and my image file will be mounted to the same place where the TCC database normally is, and TCCD process will be killed, and it will restart automatically and load the new TCC database with my nice and fine configuration. And then macOS is fully compromised. So this is already a rather old bug in the sense that this indeed happened during the COVID times, and I had a bit more time to spend quality times of some of the interesting leads what I got maybe beforehand also. So there was I had quite a long time idea related to this alias file. Actually, I think it was already like 5 or 6 years ago. I found an anomaly related that how the aliases actually work. During that time, I couldn't like quickly figure out any ways to exploit it. So, but it was always like on my on background in the sense that I need to get back to that topic at some point. And during that time, it was the time for getting back to that idea. So I report these issues to Apple at the late in 2020, and these were rather quickly fixed, or at least most of them were rather quickly fixed in 3 months or so, which is decent time from my previous experiences, also from other organizations. And they had some challenges to reproduce some of the trickeries related to the Samba mount, so we had a good discussion about it, and I actually made a virtual machine for them, which basically included web server and the Samba share, so it was like you can reproduce the full chain easily. Alias issue was silently fixed. Maybe it was not considered as a vulnerability. You can argue with that, but that's how it went. And it took over a year to get the security bounty related to this. So Apple has their own bug bounty program, which is, I think, in general, it's really good, and it's much better than it used to be with Apple. So in previous years, before this bug bounty program, when you reported some vulnerability, it might be that you didn't get credited or you didn't get any thanks, but the vulnerabilities were fixed. So compared to that, this is amazing, and they are really paying. There's many researchers in that field who have been doing the same kind of things, and after quite a while, Apple will actually go through all those and pay about those. And this is how it looks like when Apple nowadays, when they release the fixes. So if you check out the security logs, what they are showing, it looks like this. And this is also one of the things what they have done much better in recent years, because I feel that this is, although it's short description, but they are like quite accurate what they are writing over there. So a couple of years ago, still it was much more abstract in that sense. This is another example related to the vulnerability what I was reporting. And this is, I think, this is once again good example that there was a bug collision related to this TCC exploit what I used. So there was other researchers in the same field who actually found the same thing. I happened to be the first one, but there has been also many similar kind of issues with the TCC. I think that is because there's a fundamental issue that the process which is checking the TCC is owned by the user, and as a user, from the Unix original permission point of view, you always should have access to manipulate the process which is running over there. So this is like take some while to get all the things fixed related to that, if that is possible at all. All right, so thank you. And if you have any questions, I'm over here and eager to answer to those.
All right, so if there are questions, do raise a hand and the microphone will be passed to you. Let's talk quickly about the fix. Maybe you looked into how Apple did fix. You said the TCC had this permission that it was running, not the permission, but it was running as a user. Did they just change it to run it as a system service, or what did they fix there?
Actually, nowadays the SIP is in my understanding, the SIP is protecting also the path that you cannot do the mounting. So the TCC, the process is still running as an user permissions, but they have had other issues related to the fact that the process is running with the user permissions, and they have done other mitigation. But it seems that they are doing more like picking all the forgotten pieces over there and fixing those. So no fundamental fix in that sense. So there might be more dragons related to that. But there's at the same time, there's multiple researchers who are actually doing research on that topic, and they have reported huge amounts of vulnerabilities related to that. And this is coming because of the fundamental challenge, how they have implemented the extra layer of security to the TCC. So
would you say that the original way how to exploit this would be due to, and you mentioned I think this something that's old in heritage thing that's there for backwards compatibility, is that because of that or lack of security restrictions around that old system?
Well, I would say that this is not the original, fundamental way how the security structure in the BSD family is actually designed. So they have added the extra layer of security, which is kind of add-on to the fundamentals of the operating system. So typically in those cases, you know that those security measures might be helping you in some sense, but they are not bulletproof. At the same time, the functionality that the TCC is providing is actually really great, because you can control the permissions quite nicely and fine-grained. But since it's not the original fundamental idea how the Unix permission system works, or you have added more detailed configuration, it is definitely something which can be exploited many ways, and that has been shown. But it may be also that at some point it's in the reasonable level that it's the same thing if you are talking about the buffer overflows. There's plenty of mitigations. Those are mitigations, maybe not solving the original fundamental problem, but they are still slowing down, and it takes attacker much more time to actually develop the exploit. And this is the case also over there, that most likely there will be also other ways still to get it, but at least some of the low-hanging fruits should be fixed at least.
Right. And you mentioned that this had been as a hunch for you, or your gut feeling has been there brewing up years before this, right? And those 2 years gave you this chance to look at this. Now, do I understand right that the automatic unzipping, alias file, and those were the ones that you were... Did I mention something that I missed? Maybe those were the ones that you would just look at this one.
Yeah, those were exactly the things. Basically, it was the alias file, originally. So I had one case in the past, 5 to 6 years ago, and I found out that it may be able to mount disk image that way. That you have an alias, and it's pointing to the disk image, and it will be automatically mounted. Then later on, I just figure out that it can be basically anything. So maybe there's something. It's a hunch that when you have that kind of functionality, which seems to be also forgotten in the sense that it's really rare that someone is actually using those alias files in at least not in that style. So it was something that there might be some old weird functionality which can be maybe exploited because people are downloading things and doing things. So maybe we can trigger something for that automatically. And when I started to think about that, what can be triggered automatically, I started to do some research that if I'm an attacker, I send some payload, or how I can get some payload to the potential victim in a way that it will be automatically operating system will be automatically doing something. So first idea was that, okay, the Safari had the functionality that it will automatically uncompress the zip file. So that's one. And then I was starting to think, because I didn't immediately found out that there's this chain of vulnerabilities. So I tested that, okay, this works, but user need to still allow the download. So is there some way to do a zero click? So I went to the email client, and I found completely different vulnerability from there. So it was like a coincidence in that sense. So I was thinking of that. That's one way to get the file to the system automatically. My client will download some things from the mail server. So maybe that's a way.
All right. So the actual payload is residing in the ZKBD file, right?
Yeah.
The actual that's going to be executed and allows you to.
Yeah.
How do you deliver that ZKBD? Do you modify it? Do you unzip it from the zip that you have? How do you insert the code? Do you replace the file? Do you append the file? How does it?
So that folder is not in place normally. So what I did, it was...
You're going to share something, right?
Yeah. Over here. All right. So this, I used the Samba mount, and this Samba mount, in this example, it's different path. But I used the Samba mount to mount it to the user's home directory, and the ZKBD directory is not normally over there. So instead of creating a directory for that, that will be the Samba mount, and since the Samba mount is going to be over there, that folder will be created automatically, and the data inside of that is from the Samba mount, from the external resource. So that did the trick.
Okay, got it. So the gut feeling, a lot of free time, and finding logical bugs. So that's what you were mentioning, the logical bug. So logical bugs, would you say there would be a way, and I pretty much already know the answer, maybe, but would there be a way to automate and look at this? Because I think there's, in my perspective, I think there's no way. There's no fuzzing that you can do. This is you banging your head against the keyboard. But is there something that can help a security researcher to figure out?
Really good question. I think we need to crowdsource this, because these things are, I think the guys in the CTF have been figuring out more complex issues right now in this event. So instead they could be doing like finding vulnerabilities from macOS and getting bug bounties. But still, as a fundamental, I agree that it may be true that these are really hard to find, because you need to have the human labor in place. Really hard to automate also. And
I think it also comes down to the experience. How do you craft? How do you be crafty, right? How do you inject stuff in there?
Yeah. But at the same time, during this research, I felt that most of the old school Unix administrators would have found the same things if they have been looking to the same place what I was looking. So for me, it looks like there's no researchers in that field. And I've been stating this a couple of times already, but for me, it many times seems that we have like in Lord of the Rings, we have the Sauron's eye, which is always turning to some direction. That okay, now let's do buffer overflows, and we do that. And okay, now there's vulnerabilities in the virtualization platform. Let's start to research and do that, and let's do fuzzing. And that's a good thing to do. I'm not saying that, but maybe it is that everybody is going to the same direction, or at least not everybody, but most of the persons or researchers are looking to the same direction. And actually, original idea for me was that what I was thinking of with some of my hacker fellows was that how much there is like this kind of old school logic bugs hunting going on, because I haven't seen lately like any good research in that sense, except with the maybe home routers and with more dummy systems, I would say.
Right, and I would say that for the Apple in this case, even if they go to the secure software development lifecycle, they would not be able to identify that automatically unless there is a team who's actually looking. That's at the code. Most likely, this is where they rely on the bug bounty program to find or kind of that you would report them back.
Yeah, it may be.
All right. Well, with this, Mikko, I know the you already have a tea from the previous talk, but the winter is coming up, and most likely you'll enjoy another cup of a tea while searching for another bug.
For sure. Thank you, BB.
Thank you.